So if I want to find the x-intercepts, that's what solving is. Y has to be 0, because that's where the x-intercepts are, right? That's when y equals 0. So we're going to say y has to equal 0. So now when I go to solve this, this is one of those situations where solving algebraically does not help. If I move the 15 over, it doesn't do anything. So we're going to go ahead and factor it. This is a quadratic, so we're going to set up the x method to factor this. 1 times 15 makes 15. 8 on the bottom. Denominators of 1. I need two numbers, and raise your hand if you know them, that will multiply to make 15. They will add to make 8. Renee? 3 and 5. That means that if I set this up as my binomials, I would have x plus 3, or 1x plus 3, and 1x plus 5. And again, I'm trying to make 0. So if I want all of this to equal 0, this is where we'll use the zero product property. I don't need to find one number. I need to find two numbers. If I can make this equal 0, the whole thing multiplies together to make 0. If I can make this equal 0, it all multiplies together to make 0. Let's go ahead and solve them separately. I want x plus 3 equals 0. I want x plus 5 equals 0. And with each of these really simple one-step equations, we should get that x equals negative 3 and x equals negative 5. Those two numbers will be my solutions. If you wanted to double check them, you could plug them back into the original problem, or you could plug them into the factored problem. No matter what you do, you should end up getting 0 when you plug those back in.